Every day, we breathe 25,000 litres of air. A distribution centre is particularly exposed to harmful particles from exhaust fumes and dust. At Schenker in Västerås, there was a health concern. Camfil was commissioned to install its patented clean air solutions. This led to 30% lower heating costs, despite a terminal with many access gates.
Welcome to our next Metflix metsoc.mcgill chapter. My name is Panza. I'm here with Liwei and Mahmoud. Currently we are at Camfil Power Systems, and today we are going to have an interview with Joshua Kohn and Sophie Belanger. Before starting, I would like to thank you both for taking your time and having us here. So we're going to start with a couple of general questions first. Tell us about Camfil. What does it involve and what is your role here at Camfil?
Hi. Well, first, thank you for interviewing us. So what is Camfil? Camfil is an air filtration company. And specifically here you are with Camfil Power Systems. So we focus really on air inlet filter for gas turbine and other turbo machinery. I work as a product manager.
And my name is Joshua Kohn. I work as the R&D Manager. When we're using these filters on gas turbine power generation applications, it's all about keeping these engines making as much power as they can, as reliable as they can, and burning the least amount of fuel to make that power as possible. So the goal of the air filters here is really to keep the air as clean as it can going into the engines, to make sure that these engines, when they're running on very corrosive environments, when they're running on next to the coast, when they're running in very dirty environments, when they're running on oil and gas applications in refineries, you want to make sure that all these contaminants don't go into the engine and then rust them out, needing costly repairs every couple of years. So to make the power grid as reliable as you can, we use these air filters.
How materials engineering students or interns have been involved in different departments and particularly?
Right now we've got, I think, 2 material engineering interns. One of them works with supporting the product team, one of them works with supporting the R&D team. So the type of research we've asked them to look at was, by example, looking at a new resin to coat some of the media and see if they can do a research on how those resins age with time and how do they react in different environmental conditions. Our filters will be supply an area as diverse as an offshore platform or like a desert in Saudi and or North Siberia where it gets really cold. So material reacts in different ways in different environmental conditions, and that's really important for us to know upfront. That's one of the examples that comes to mind right now.
Another example is the filters we make have to be waterproof. So there's a lot of work being done on different hydrophobic or oleophobic properties of the filter mediums. So we have a couple different test methods that we do here that we have our interns working on that help us then specify the right types of materials to use in finished products.
When we look at self-cleaning type of filter, what we use is compressed air and a rapid pulse of air to clean those filters from the dust that accumulates. So if you have your airflow from the outer in, and you'll have a dust cake on the top of your filter, and you're, by example, in a sandstorm condition where the dust keep up coming with really high concentration and really rapid rhythm, you don't want your filter to clog. You don't want the pressure drop to start shooting up and, by example, tripping your turbine and causing some unexpected downtime in a power plant. So we clean it with a shot of compressed air that will release the dust out back in the environment. And we keep pulsing those filters until they go down to a certain level of pressure drop. So for, by example, the Middle East region, these are the type of filters.
Your friendly advice to fresh graduate students?
That's a tough one. Yeah, be curious. I think when I started working, I never really thought air filters could have anything interesting whatsoever. But the more you know about about a subject, the more you kind of understand the complexity of it. And you know, it's been me 11 years. I keep learning something every single day. So be curious. Whatever subject you're going to go into, whatever field of industry you're going into. Thank you.
I like that advice. There's always problems worth solving. You want to be finding interesting problems to work on. Engineering is all about being curious about how things work and always wanting to do better. I found in industry, your job changes every couple of years. You're never doing the same task twice, which is interesting. And I've always found that programming is very underrated. There's always a lot on that side to be done.
Thank you.